We're happy to welcome you on our today's tap room. My name is Alex Korletz. I'm the solutions engineer here at Starwind. And the main topic we will be talking about on this tap room is what is the stretched cluster, how to use this, and how not to lose your mission critical data by setting the stretched cluster. Okay, so every one of you guys, I believe, knows that today more and more companies are expanding beyond a single location. So, for example, a small online shop had single office somewhere in Los Angeles. Where they grew up, they decided to open the second office somewhere in San Francisco. And having one database for both locations was not mandatory, so they bought a server on the second site and created another database. And like months have passed, number of clients across both offices increased significantly. And once they have faced server hardware failure on one of their offices, which was resolved at the end of the next day, and obviously that led to money loss, big amount of money. So they decided to somehow back up their data and avoid the production downtime. But how to do that? Well, yes, it's possible to shorten the downtime of the production by using backup software and restore from the backups, or even make an active passive scenario by replicating the storage between the sites. But anyway, the downtime still exists, so it is not an option. There are no mistakes to be made because of money. So the remedy for this kind of situations is the stretched cluster. And in the stretched cluster, the joint servers act as a single system and provide high availability and load balancing for the services, at the same time not being tied to a single location. So basically, the Starwind, just live demos in my mind. So basically, the cluster nodes can be located in different buildings or even cities. Moreover, the live migration of these services and virtual machines becomes available, which helps to quickly migrate the critical production to another site in case of any disaster. And in order to make the cluster sources highly available, the option would be to create active-active replication between the sites, where you have your data synchronously replicated between the locations, thus being sure that you have the latest changes on both sides. And even one of the sites will become offline, you'll have your database or VMs running from the second site. So the stretched cluster can be configured between the buildings within the same district, but of course this configuration has some drawbacks. The main, I guess, is called the split brain. So what if something will happen with the network between the buildings? Both servers in the cluster will write the data on itself, and when the network will go up and running again, at that moment, when the synchronization of the data will start, you'll get the split brain and the data corruption respectively. So the question of network connectivity especially raises if we're talking about the stretched cluster between the cities. Quite often the companies have a single connection to the partner office, and this connection goes over the miles. So the chance for this connection to be cut off increases. So let me tell you some recommendations regarding the proper stretched cluster installation. Okay. Since I'm not a spy and do not want to share some information, including the wrong info, about other storage vendors. For me personally, working at StarWind, it will be great to describe the way we do the stretched clustering using our own product. If the minimal requirements are met, StarWind Virtual SAN will help you to create highly available device between the cities using active-active replication. And of course, we highly recommend to have at least 2 separate networks between StarWind cluster nodes. That recommendation is applicable to, for example, 2-node setup. So like node 1 on side 1, node 2 on side 2. Here we can use the heartbeat failover strategy. And the heartbeat is technology that allows avoiding so-called split brain when the HA cluster nodes are unable to synchronize but continue to accept write operations from the clients. And they do that independently. So it can occur when all synchronization and heartbeat channels disconnect simultaneously, and the other partner nodes do not respond to the node requests. And as a result, StarWind service assumes the partner nodes to be offline and continues operations in a single node mode using the data written on it. And like if at least one of the heartbeat links is online, StarWind service can communicate with each other via this link. The service mark the device with the lowest priority as non-synchronized one. Subsequently, it gets blocked for further read and write operations until the synchronization channel resumed. Then the partner device on the further synchronized node flushes data from the cache to the disks to preserve data integrity in case of the node goes down unexpectedly. And it is recommended to assign more independent heartbeat channels during replica creation to improve the system stability and avoid this split brain issue. And like with the heartbeat failover strategy, the storage cluster would continue working with only one StarWind node available. So the requirements for networks in this case are next. For the management heartbeat network, we need at least 100 megabits per second network. And for the iSCSI and synchronization networks, we need at least 1 gigabit network or higher. Of course, like we recommend to use 10 gigabit or higher bandwidth in order to avoid any bottlenecks on network level. But of course, like it depends on your particular scenario. So sometimes it becomes impossible to create a 10 gigabit network between the cities. So you can use only 1 gig or even less. Okay, and the second failover strategy is the node majority. So this strategy ensures the synchronization connection without any additional heartbeat links. The failure handling process occurs when the node has detected the absence of connection with the partner. So the main requirement for keeping the node operational is an active connection with more than half of the HA device's nodes. And the calculation of the available partners bases on their votes. So in case of a 2-node HA storage, all nodes disconnect if there is a problem with the node itself or with communication with the within the cluster. So therefore, the node majority failover strategy does not work in case if only 2 synchronous nodes are available. To apply the strategy, the third entity is required. So it can be a witness node, which participates in the nodes count for the majority, but neither contains data nor like process client requests. So node majority floor strategy allows tolerating failure of only one node. If two nodes fail, the third one will also become unavailable for client requests. So like if replicated between two nodes, the witness node requires additional configuration for HA device that uses node majority. The replication of HA device among three nodes requires no witness node. So yeah, the node majority flow strategy network design is next. So it's very simple. We need at least one network between the nodes for management, heartbeat, and synchronization at the same time. And it must be at least 1 gigabit network or higher. And of course, like we recommend at least 10 gigabits in order to have good performance and not to cause any bottlenecks for your production. Okay, so I guess the best one would be just to go straight to the technical part of our webinar and see how it's configured, how it looks like. So let's just finish with the presentation at this time. And okay, so here we have three nodes, three Hyper-V nodes running Windows 2019. And we have some kind of witness node functionality included in our installation over here. So two nodes would be used for storing the production data, and the third node is working as a witness node, just storing, just like looking at another two nodes and ensuring that nothing happened to the networks, nothing happened to devices, and voting to the nodes. Okay, so yeah, let us just simple like create the device and do the like all the steps required for the configuring a node majority setup. So let's proceed with simple add device. We'll add hard disk device on the first node. We're creating it. Okay. So we will name it somehow GSV2. We will specify the location it will be stored. Let's make it some kind of like 5 gigabytes as an example. Okay, native 4K blocks, thick provisioned. Let's do not assign the cache on it. Okay. So we just created a image file on one of the nodes, and now we need to replicate it on another node. So what we do is just go to the replication manager, add replica, synchronous to the replication. We will specify the second host, so it will be 68.13.61. Oops, just missed that one. So here we need to specify the failover strategy. So as I mentioned previously, heartbeat can be used with only two nodes, but at least two physical connections between the nodes must be presented. So we need to use just the node majority if one of the networks is available. We will choose that one. We will create new partner device on the second node. We'll specify the location as well. And when we are specifying the IP addresses of the synchronization and iSCSI connections, so we need just to specify a single synchronization channel. So it can be this one. Let's use this one for the synchronization. Okay. Yep. So now we do not synchronize the device because it's empty after creation. Okay. And let's close that one, and let's ensure that we have this device seen on the second node. Okay, let's close one. Let's refresh our Starwind management console, and yeah, so we can see that this device already created on the second node, and the device is synchronized. So now we need to add the witness host to this configuration, and all we need to do is just to go to this device we just created, go to the replication manager, and add replica. So now we're choosing the witness node. We're specifying the IP address of the witness node, 1362, and we're specifying the storage that will be used for storing the logs of the device. Okay, so now we need just to choose the same synchronization network that was used. So let's just go with that one. Okay. Create replica, close, and close this one. So now we can see that on the first node we have the Starwind device. We have information about it. On the second one, the same information. And we have appeared the same device on the witness node. And we can see that it works in witness mode. So now if we will lose one of the nodes, Starwind will see that one of the nodes is still active. The witness node is still active. So yeah, we can just proceed with the production workloads, and nothing will happen with our data. So let's just simulate. So like, for example, we have the failover cluster manager over here. We have our first CSV already joined the failover cluster manager. And we have also the virtual machine running now on the second node. So let's suppose something happened with the second node. How Starwind will react on this one? So again, we have just only one network. Let's just double check that. Replication node interfaces, as you can see here, just a single network. So in other scenario, Starwind will just catch the split brain scenario because heartbeat, the only one heartbeat is assigned. But yeah, we have the witness functionality over here. And let's simulate the power failure of the second node. So just 1 second, I will do something with the second node. Okay. Okay, oops, something happened with the second node. And what we're expecting from the Starwind is that this virtual machine would be moved to the first node and continue running like nothing happened. So we need just to wait a couple seconds. As you can see, it already changed the node. So in this case, in case of hardware failure, Hyper-V by design will just reboot the virtual machine using the compute power of the first node. So yeah, as you can see, everything is working fine. And that's basically the proof of concept, how the stretch cluster works. So yeah, I guess now would be just the part of a questions. And let me just open the slide of the questions. Okay, so gentlemen, if you have any questions regarding the stretch cluster creation, feel free to ask them in our questions tab. Or maybe if you have any other questions regarding Starwind or something else. So Adam Findlay asks, is it possible to run the SCSI sync network on a connection less than 1 gigabit? What will happen? So yeah, basically we just tested the Starwind on the networks less than 1 gigabit. But it totally depends on your particular environment. So if you have the virtual machine, let's say 50 gigabytes, and that's the only virtual machine you're running, I guess it would be completely enough for Starwind to perform a replication and maintain the replication between the nodes with even like 100 megs. But of course, the higher, the bigger workloads would cause Starwind device to automatically desynchronize because the queue of the write operations is will become too high in this case. So Alex Hernandez asks, does it always reboot the VM? Not really. So if you will perform a live migration, the graceful shutdown of the node, for example, so the virtual machine will not reboot. It will continue running like nothing happened. But how Hyper-V works by design is that in case of unexpected failure, I mean the hardware failure, for example, Hyper-V will always reboot the virtual machine. But have no fear. So if you will assign the amount of RAM cache, for example, on Starwind device, we have also RAM cache replicated across the nodes. And thus, when one of the nodes will become inactive, the cache that was on the second node will flush to the underlying storage, and thus Starwind will ensure that you have the latest data and latest changes on the virtual machine when it will be booted up again and running. So Michael Gillespie asks, do you need 3 hosts to do this type of stretch clusters? What if you have 2 host environment? So yeah, as I mentioned previously, for the node majority, you need at least 3 hosts. So it can be not the host with the same compute resources and storage capacity. So it can be even a laptop, for example, if it works 24/7 and if it can work like that for a couple of years. So for example, like the server with the minimum amount of compute and storage can be like a witness, can work like witness. But for the node majority, yes, 3 nodes are the mandatory requirement for working properly. Okay, so waiting for questions. Is this webinar would be somewhere in the social media? Yep. So after our webinar, I guess next week it will be released on our website and also on our YouTube channel. Okay, gentlemen, do you have any questions left regarding webinar, regarding Starwind, maybe? Okay, I suppose that there are no more questions left for now. So yeah, I guess then thank you for joining the webinar today. So you will be able to ask all the questions if you may have any in our social media after the actual webinar. So yeah, again, thanks for joining this webinar. It was a pleasure for me to talk today about the stretched clusters. And yeah, thanks again. Have a great day and fly safe. Goodbye.